All right, hey, welcome to today's webinar on storage options for building a SQL Server Failover cluster instance in Azure. My name is Dave Bermingham. I am a Microsoft Cloud and Datacenter MVP, and I work for SIOS Technology as the Director of Customer Success. So today's agenda, we're going to look at the Azure infrastructure and what that means in terms of what you need to do to build highly available deployments of SQL Server. Then we're going to look at specifically SQL Server Failover cluster instance storage options. We're going to review all the different options, discuss some of the limitations, and have some demonstrations of the different options. And then we're going to look at some performance comparison between the different options and some cost comparison. So once again, we're talking about a SQL Server FCI running in Azure Infrastructure as a Service. So it's very specific. We're not talking about Azure SQL or any hosted database as a service platform. We're not talking about managed SQL Server instances. We're talking about you deploying SQL Server on your own virtual machines, instances, whatever you want to call them, running in Azure, and you're installing SQL Server, and you need to provide for high availability. Of course, there's two main options when you talk about SQL Server high availability. There's the always-on availability groups, which has some built-in replication functionality, which might be the best choice for you. It does require the Enterprise Edition for the fully featured version of that. And that might be, the cost might be a limiting factor, or you might be running hundreds of databases and AGs just don't really scale up to multiple hundreds of databases very well. So a failover cluster instance is going to be a good option. You can run a 2-node cluster with SQL Server Standard Edition, so you're going to save some money if you don't need the Enterprise Edition for any other reason. And it doesn't matter how many databases you have. So we're going to take a look at that specific configuration. So before we jump into SQL Server and FCIs, you got to understand a little bit about Azure's infrastructure. So way back when Microsoft Azure was first introduced, the way to provide redundancy was through fault domains and update domains. And what that was is if you put all of your SQL cluster nodes into an availability set, it would spread those instances across different fault domains as well as different update domains. And so what is a fault domain? So a fault domain you can really think of as kind of a rack of servers that are independent from one another. So they shouldn't share any dependency on networking or storage or power, but they do reside in the same geographic location, the same data center. With that being said, Microsoft, if you leverage the fault domains, Microsoft guarantees you 99.95% that availability, that at least one of your instances will be online. So that's their SLA. The update domain, on the other hand, if you think of each rack having multiple physical servers, the physical server represents an update domain. Occasionally, maintenance needs to be done at the physical server layer. And so by leveraging the update domains, Microsoft promises that they won't update more than one update domain at a time. So at least you should have one of your servers always running if Microsoft decides to do any sort of update on those physical machines. So that's the update domain. There's many more update domains than fault domains. And so when you put your servers in an availability set, that automatically will place your servers in different fault domains. So in this instance, this case, I put 2 SQL Server instances and a file share witness in an availability set. And you can see that instance 1 is running on update domain 0. The backup instance of SQL Server is update domain 1, and my file share witness is an update domain 2, and of course all different fault domains. You'll want to do the same thing with all your supporting infrastructure. So if you're managing Active Directory, put your domain controllers in an availability set. put your web servers in an availability set. That distributes it across fault domains and update domains and gives you some redundancy. Again, qualifies you for the 99.95% SLA. Now, Microsoft has since introduced this concept of availability zones, which is the preferred method of providing high availability, in the current year. So, with availability sets, now we go from 99.95% to a true high availability percentage of 99.99%. And what that is, availability zones, or AZs for short, are different data centers within each Azure region, typically 3 or more AZs within a region. And by leveraging AZs, you're going to put all your cluster nodes in different AZs. And if you're using a file share witness, you put your witness also in a different AZ. Of course, you can use a cloud witness in Azure, which would probably be preferable. But anyway, by leveraging availability zones, now you get the full 4 nines of availability, which is kind of the entry level to HA. So I highly recommend that whenever possible, you leverage availability zones for your SQL Server FCIs or your SQL Server AGs or any high availability configuration. And Microsoft will guarantee at least one of those nodes will be running 99.99% of the time. They don't guarantee anything about the services running in those instances, but the actual instance will be online. So that's why we need to still cluster SQL Server inside the instance to provide availability at the application level. So when it comes to SQL Server FCI, you probably are aware, if you've been in SQL Server for any amount of time, that if you want to build a SQL Server failover cluster instance, it relies on some sort of shared storage, whereas the always-on availability group option has replication built into it. The FCI, all your data resides in one location. Normally in an on-prem data center, that would be a fiber channel SAN, iSCSI array, something like that. In Azure, there's really 4 options. So Microsoft lists them in their documentation, which you can see here. There's the option of the Azure Shared Disk, which is their newest option. Something that basically you could take your normal Azure Premium Disk and enable, it's called max share. So you can increase the number of clients that can connect to that shared disk. And then at that point, you can present it to the cluster because it supports the SCSI reservations. You can use it as a traditional cluster disk. And you can also enable on that disk, you can enable zone redundant storage, or ZRS, and that will allow you to build clusters that span availability zones. So you can do this in an availability set or availability zones. I say availability zones, we'll see later, there's only a limited number of regions today that support that, so that's important to check out. It does support file streams, but however, it doesn't support the Azure Blob Cache, so you can't take advantage of caching on your storage, which is sometimes going to be important. The other option, it's been around a little bit longer, is the Azure Premium Files share. So Azure offers a service where you can have hosted SMB file shares. Azure manages the file shares. You can enable redundancy of the file share so that your storage is highly available, distributed across availability zones. And you can use an SMB share for building a SQL Server FCI. It does require at least Windows Server 2012 and SQL Server 2012. You can span availability zones or availability sets. However, it doesn't support file stream or the Azure Blob Cache. The other option they mention is Storage Spaces Direct. So S2D is it was introduced in Windows Server 2016, so you need at least 2016. Requires at least SQL Server 2016. But the biggest limiting factor with S2D is not supported across data centers. So Microsoft doesn't support it when you're deploying across availability zones. So you're limited to the old style cluster where all your cluster nodes would reside in the same AZ. For that fact alone, I don't recommend it. You really want to span availability zones at this point. There are other better options for you. But it does support file stream, and it does support the Azure Blob Cache. Microsoft also, in their documentation, talks about third-party resources, including SIOS Datakeeper, and that's why I'm here today. We do a lot of business in Azure and other clouds and on-prem. Datakeeper is a software solution. It's been around for a long time. I've been here 18 years, and it was running back on 2003. So it enables what we call a SANless cluster. It's software that does block level replication, so it keeps the data in sync across all the cluster nodes, and then it integrates with failover clustering through our own cluster resource that mimics a shared disk. So the cluster behaves like it's a shared disk cluster, but when a failover occurs, instead of controlling the disk locking, it controls the mirror direction. So whichever node is active, all the writes occur there and are automatically replicated back to all the remaining nodes. This works on all currently supported versions of SQL Server and Windows. Of course, it does support failing across availability zones. It even supports failing across regions with the asynchronous option. So it supports both synchronous replication, which is typically used between availability zones, or asynchronous if you want to replicate greater distances or do some sort of hybrid cluster on-prem into the cloud. So there's lots of options there. And it does support file streams and the Azure Blob Cache. So let's take a closer look now at each of those solutions. The first solution we mentioned is Azure Shared Disk. Azure Shared Disk, again, is just a regular Azure Premium disk that you enable max shares to share it with all your cluster nodes. And so once you configure it, it behaves just like a traditional cluster disk. You'll register it in failover clustering, and at that point, you just install your SQL Server FCI like you normally would on-prem and choose the Azure Shared Disk as your storage option. Again, with enabling the zone redundant option, then you can also span your cluster across availability zones. So what are some things to consider with Azure Shared Disk? You can't enable the host caching or disk bursting. You can't do the Azure SQL backup. You can only do Azure Disk backup. You can't use Azure Site Recovery, so your DR options are limited to things like traditional backup or log shipping or configuring an AG from your cluster, FCI to another instance. So you really have to think about what you're going to do for disaster recovery. The Azure Disk Encryption is not supported, so you'll have to think about server-side encryption. The zone redundant option, which of course you're going to want to enable for high availability, will introduce additional latency on write operation, which is normal for synchronous replication. We'll talk more about that. But one of the big things is to enable zone redundant storage. It's only available currently in 4 regions. So West US 2, West Europe, North Europe, and France Central region. So if you're already highly invested in another region, this might not be an option for you. So keep that in mind. I'm sure Azure will be rolling this out to other regions in the future, but for now, that's the regions that are supported. And one of the biggest hang-ups I have with it is there's no way to test a zone failover with a zone redundant storage. You can configure it, but the storage does not fail over unless Microsoft, whatever mechanism Microsoft put into zone redundant storage to detect a failure of a zone, you cannot trigger it as an end user. So there's no way to test the failover to ensure that it actually works the way you expect it to work. So for that reason, I hesitate to implement or recommend implementing it because there's no way to test zone redundant failover. And that also introduces kind of another conundrum is if you think about your storage running in AZ1 and your SQL Server active instance running in AZ1, that's great. Your storage and active cluster node are in the same AZ. What if the cluster node fails over at AZ2? The storage is still going to reside in AZ1. So now you're accessing your disk in a different AZ, which is not ideal. Actually introduces additional latency, and I've measured it and I'll show you later. But you're going to want to keep an eye on that and think about how you want to handle that. Minimally, you want to make sure whenever possible your instance is always running in your primary zone with your storage. Hopefully Microsoft will introduce some kind of mechanism to allow the storage to fill over, and then maybe you could tie together your clustered instance with the storage to make sure they're always running. But for now, there's no way for us to tie them together, and there's no way for us to test a zone failover. So I'm not super confident in the solution until I actually see it working. Here's some of the performance measurements I took. So I used disk speed. You can see the parameters I used: 100% writes, 8K writes, and I did 3 tests. So I ran a test with just hitting a local redundant disk, and then that's the first column. And then I enabled a zone redundant storage, and I ran the same test. See a slight minimal increase in latency, still pretty comparable, not too bad. Then I did the test I mentioned earlier. I switched the instance so that SQL and the disk was being accessed from the remote AZ, but the storage still lived in the original AZ. And you can see I measured about a 2 millisecond increase in average latency. So again, take this with a grain of salt. This is one test parameter. You're going to want to, obviously take a look at it, see how it works for you in your environment. But definitely something to consider when we're thinking about Azure Shared Disk. So now I'm going to jump and do a quick demo of the Azure Shared Disk, show you how to get it configured, and then we'll move on to the next option. All right, so now we're going to check out the Azure Shared Disk. And so in your Azure portal, you're going to go to the disk section, of course. Assuming you already have a storage account created and in the same region as your the nodes in your cluster. In this case, West US 2 is going to be the region. We're just going to go ahead and create a disk. I'm going to put it in the same resource group that I've already pre-created. I'm going to give it a name, shared disk, and again, make sure it's in the region that I want my my cluster nodes are residing in. We're not going to put it in an availability zone because it's actually going to span availability zones. I'm going to click on change size, and here is where we're going to change it from premium SSD locally redundant storage to premium SSD zone redundant storage. Okay, and then obviously pick the size we want to use, and we'll click OK. And then in the Advanced tab, we're going to choose Enable Shared Disk. And max shares, I think this is limited by the size of the disk, if I'm not mistaken, but for a 2-node cluster, 2 shares is all you want to choose. And because it's shared, we can't enable disk bursting, so that's not an option here. So we're going to go ahead and just review and create that disk now. Okay, validation looks good. We'll click Create. All right, deployment's in process. We'll let that finish. Okay, looks like we've created that disk. Now we need to attach that disk to our virtual machines. So in this case, I have my virtual machines that I'm running in West US 2. I have a primary and a secondary. I also have a domain controller in my lab. So let's open up the primary server. And we're going to look at the disk associated with that. Of course, we have the OS, the system disk is already there, but we're going to create a new disk. Now, this is very important. So we'll click on Create and Attach a New Disk. Now, I'm sorry, we don't want to create a new disk. We want to attach an existing disk. So we're going to click on Attach Existing Disk. You might be tempted to just go ahead and browse out to that new shared disk that we just created. But before you do that, you have to change the host caching to none, because shared disk does not support any host caching. And I'll just go ahead and show you. If I had actually chose that first, look, this is grayed out. I can't change it now. So I'm going to have to delete this and do it again. And this will drive you nuts if you don't the first time you do it. So you have to change the host caching to none before you attach the shared disk. Isn't that crazy? But anyway, once you've done that, we'll click Save. And so that shared disk is now being attached to our primary server. Okay, so that's attached there. Now let's jump over to secondary server, and we're going to also attach an existing disk. Same thing, change the host caching to none, and then we should be able to connect to the shared disk. It says, look, the disk shares one of two, so it already sees that it's already connected to one. So now we're going to connect it to the second share, and we will go and save that. Okay, now that I attached those disks, I'm starting those virtual machines up. And you could attach them while they're running as well. That's fine. So once these start up, I'm going to RDP into the primary server, and I'm going to show you how to attach that shared disk to as a cluster disk. So I'm going to pause the recording, and we'll jump back when I RDP into primary. Okay, so I've connected to this primary server and just logging in now. First thing we need to do is go into disk management, and let's attach that new disk, format it. So I like to use the old style of disk management. You can do whatever you want. You see, it already noticed it recognized the disk. So we're going to initialize it. Now we should have this 1 terabyte disk here. It's online. We're going to format a volume. We'll assign a drive letter. E should be fine. Use best practices. I'm just going to choose the default, but obviously for SQL Server, I think there's some better practices for the allocation unit size. And so choose that and click Finish. And so that is bringing the E drive online on the primary server. So here we go. Now I'm going to open up Failover Cluster Manager, which I think I have a shortcut for. Here we go. And so I already had a cluster, pre-configured. I'm not going to go through the whole process of creating clusters or even installing SQL Server Failover Cluster instance. I'm going to assume you have some experience with that. This is a cluster disk that we previously had. I'm just going to remove that for now. And remove it. Okay, so we're going to add the disk that we just created. Here's the new cluster disk, 1 terabyte. And here it is. It's now in available storage. So at this point, I could bring it online. I'm sorry, I could install SQL Server and use that shared storage. During the installation, when you install SQL as a new FCI, it will recognize that shared disk in available storage, and you can create your cluster that way. So I think I showed you everything you need to know about using that shared disk resource. Okay, so now we're moving on. We're going to look at the Premium File Share option. So as I mentioned, Azure offers a service, Azure Premium File Shares. So it's a hosted SMB service. You can create file shares. You can create redundancy for those file shares so that they span availability zones. And then the more current versions of SQL and Windows will support using an SMB share as cluster storage. So there's there's a couple things that you need to know when you're installing the cluster, and we're going to walk through that in the demo to show you how to use Azure as a SMB share instead of a shared disk. But this is an option that you can do this on-prem. Microsoft introduced this when they came out with the scale-out file server, transparent failover. All of a sudden, SMB3 was a lot faster and much more resilient to be able to host back-end databases like that. So what are some of the things you need to consider when you're looking at premium file share, some of the limitations? Again, depending upon the version of Windows, you may or may not be able to support Distributed Transaction Coordinator. File stream is not supported if you're using an SMB share. The database snapshots are not supported with Azure File Shares due to sparse file limitations. And since database snapshots are not supported, the CheckDB for user databases falls back to CheckDB with tab lock. And tab lock limits the checks that are performed. The DBCC check catalog is not run on the databases, and service broker data is not validated. The CheckDB on the master and MSDB database is also not supported. And databases that use in-memory OLTP features are also not supported. So if you don't need those, then this might be an option for you. So I'm going to show you now a quick demo on how to provision the premium file share and what magic you need to work when you're actually installing the SQL Server FCI so that you can use an SMB file share. Okay, so in this demonstration, I'm going to show you how to provision an Azure Premium File Share, and then what you need to do to use it in your cluster. So here we are in the Azure portal. Here are in the storage account, there's a section called File Shares. So you want to obviously first create a storage account in the region of your cluster. So this storage account will show you here. I've created the kind of storage account is file storage, and I created it in West US 2. So within this storage account, we are going to create a file share. And when I created the storage account, I made sure it was zone redundant, and that's important. You want to have that redundancy so that you can have a cluster that spans availability zones. So definitely make sure your storage account is zone redundant, and it's the access kind is file storage, and performance is premium. So once you have that created, you'll click on the file shares, and we're just going to go ahead and create a new file share. Pretty simple file share. That's pretty, I'll just say SQL FCI. Okay, provision capacity. So obviously choose how much capacity you need. That will also determine the max IOPS and your burst IOPS and your throughput rate. We're going to use the SMB protocol, and we'll go ahead and create it. Okay, so once we've created that file share, we're going to click on this connect button within the file share we just created, and that's going to give us this PowerShell script over here on the right. And this PowerShell script is based upon the drive letter we choose up here. So this will be the drive letter that we're actually going to mount this SMB share as. So pick a drive letter that's going to work for you. I'll just choose the L drive, and then let's go ahead and copy this PowerShell script. And then we need to run this PowerShell script on both nodes in the clusters. I have it up on secondary, and I'm going to paste this script. And then we'll run this PowerShell script. Again, we're running this elevated privileges here. So now I have this L drive. It's mounted. We should be able to see that here. We have this L drive. And we'll create a folder. Call it data. We're going to use that when we install SQL into cluster, that folder. Let's go back to this server and see what's going on. Okay, things are running a little bit smoother now on primary. So we'll go ahead and run this PowerShell script here. And there we go. So now we should see the L drive, and we should see that folder we already created. Yep, there's the data folder. So now we're ready to move on to the next step, which is installing SQL Server, which I think I have downloaded here, SQL 2019. We'll run the setup. So again, this is going to be very much like a regular cluster installation, but there is one wrinkle. And again, this is pretty well documented. And this is not specific to Azure per se. I mean, you can install a SQL Server Failover cluster instance that leverages SMB storage. You've been able to do that for a while now. So this really applies. It's the same thing. You're just using the Azure hosted SMB share. So I'll just show you real quick in the area you need to concern yourself with in the installation. All right, I already had a default instance installed on this, so I'm going to go with a named instance. Specified network name is invalid. The name cannot be. Name cannot be what? Name cannot be null or empty. Got it. All right. Didn't fill that in. Okay. Okay. Here we go. So normally you would see your shared disk here. There are no shared disk, so we're not going to select a shared disk here. And we'll have to specify an IP address. So something on this subnet. Should be available. Use your best practices here, security. Hope I remember my password. I didn't remember my password. I think I know what it is. Hold on, let me try it one more time. Okay. So here is where the magic occurs. This is where I always want to add my SQL Server administrators. In the data directory, though, is where we're going to specify the SMB share. So this was a little confusing at first, so I'm going to walk you through the process here. So let's see. Our share that we created, let's go back to our shares. Let's see, where are the shares? The share we created, we should be able to see the SMB name. Let's see. Oh, I'm sorry. It's on the storage account. Yeah, here it is. Sorry. So properties, this is the storage account name. And so when I first tried this, I was just using this URL. But if we look at the documentation, it talks about, it shows you exactly what to do here. So let's look at it right here. We want to use in this format. So // storage account name and slash the file share name that we created / the folder name that we created. So we want to make sure we use we got to get the file share name and the folder name in this connection string here. So let's go back there and let's see. Well, let's copy what we have. And remember the directions of the slashes are going to be the opposite of what we just copied. So, and we want to get the beginning of that. Yeah, storage account name. Back whack / SQL FCI, but also the name of the folder we created, which I believe was data. Let's double check that. Yeah, data. So where are we? Here we go. Data. And then you can see all the subdirectories are going to be created for us here. So you might want to change tempdb, keep it local. That's fine, or you can put it on the SMB share. It's totally up to you. You might want to keep it local for performance reasons. But that's the big difference. And so now the rest of the installation should be fine. So when we show the SQL Server service account has full control, share permissions, which we know it does. We ran that script to connect and install. So I'm going to pause the recording, let this install. But that was the big. That's what you need to know about using SMB file shares to create SQL Server FCIs. All right, so the install completed. Now if we look in that folder, we can see that laid down all the databases, the master, MSDB, all that good stuff. And in failover clustering, it looks like this. So we have this new SQL role, and where you might expect to see some kind of storage resource, you don't see the storage resource. So it might be a little bit worrisome at first, but that's okay because it's all on the SMB share. So that's what it's supposed to look like. All right, I hope that helps, and we're going to move on now to the next section. Okay, so moving on, now we're going to talk a little bit about Storage Spaces Direct. As I mentioned earlier, it's not something I recommend people use for building SQL Server FCIs. There are at least 3 better options out there. The biggest limitation with S2D is you're limited to a single AZ. You cannot use S2D to span data centers. Microsoft doesn't support it. And you look in the documentation, they'll tell you it's not supported, and they want you to use the old availability set to span fault domains but still reside in a single AZ. The same holds true for other cloud platforms. If you're looking at AWS, you can't span availability zones there either. You'll read the documentation and they might show you how to do it, tell you how to do it, but tell you it's not supported and that you shouldn't do it. Google Cloud, they ignore the advice completely and they just tell you how to do it. But when it comes down to it, Microsoft does not support S2D that spans data centers. I wouldn't do it. Performance isn't all that great to begin with, and again, there's better options out there. But having said that, I'm not going to talk too much about it. I'm not going to even go into a demonstration because I would advise against it, primarily because it doesn't support cross-AZ deployments. And then, if you're looking for disaster recovery with it, which you're definitely going to want to get it out of the single AZ, it only supports crash-consistent Azure Site Recovery option. So, moving on now to the HADR options with SIOS Datakeeper. Again, I work for SIOS, so full disclaimer here, but we are in the Microsoft Azure documentation, so definitely want to check us out. We have lots of great customers. We've been doing this for a long time, and Mr. Klee can vouch for me as well. It's a really great solution. So SIOS has something called SIOS Datakeeper. So just a refresher, your traditional Windows failover cluster, you have 2 or more nodes, normally requiring some shared storage, which is either not available in the cloud or represents a single point of failure, or in your primary data center, it's not a viable option if you want to stretch your clusters across data centers. So what we do is enable what we like to call SANless clustering with SIOS Datakeeper. And it's still 100% SQL Server failover cluster instance, Windows Server failover clustering. Nothing's changed. All your features, all the way you configure it and manage it is all exactly the same as you're used to with your traditional shared storage failover clusters. But instead of using a shared disk, you can use locally attached storage. And what Datakeeper does, it does synchronous or asynchronous block level volume replication to make sure the data is in sync across all the cluster nodes. And it integrates with failover clustering through our own cluster resource called the Datakeeper volume. The Datakeeper volume takes the place of the cluster disk. So when failover clustering detects a failure, of course it will fail all the resources over, including the Datakeeper volume resource. And when the Datakeeper volume resource comes online on node 2, that reverses the mirror direction. So instead of controlling disk locking, it controls the mirror direction. So now with the disk unlocked on node 2, SQL Server starts up, the clients are redirected, failover happens, the replications automatically redirected to the other node. And so failback will be easy, once you're ready to come back. This is a simple 2-node cluster, but we do support multiple targets. So picture here is a 3-node cluster where 2 nodes, you might be doing synchronous replication for high availability, but at the same time you're replicating off-site for disaster recovery, maybe doing asynchronous replication, maybe between cloud regions or even between cloud providers or hybrid cloud configurations. Really, again, Datakeeper has been running for a long time. It's been around since Windows 2003. And so it supports physical servers, virtual machines, cloud instances, all the different cloud platforms. You can even mix and match some physical to virtual, virtual to cloud, any combination. So hybrid cloud configurations obviously are an option. So this represents here just one of the many possible configurations, 3-node cluster, all replication. But we also can support your traditional shared storage cluster if you're looking for a solution that allows you to extend a shared storage cluster to a node off-site. We can work in that option as well. So the failover locally will still control disk locking, but at the same time you're replicating off-site for disaster recovery. So if you lost your primary data center, things are ready to go either automatically or manual push button recovery on node 3 over there in the third site. So now I'm going to jump over and I'm going to show you a quick demonstration of SIOS Datakeeper. All right, so now let's take a look at SIOS Datakeeper and SANless clustering. So again, SIOS Datakeeper is software that's going to run on each of the cluster nodes, and it's going to replicate locally attached storage either synchronously or asynchronously between the different the nodes in the cluster. And so first thing we're going to do is just attach some regular disk to each cluster node. So here, Virtual Machine Manager, we're going to go in on the primary server. We're going to just add some disk. So still, you see, it still has the shared disk we added earlier. So let's add a new disk. And on this disk, we can use host caching. So that's a benefit. We can use host caching here on this data disk. And local redundant is fine. We don't need zone redundant because we're going to provide the zone redundancy with Datakeeper. So that's fine. And then whatever size you want to use for testing, or set your IOPS and whatnot. So just the only thing you need to make sure is that each server that you want to have in your cluster, when you replicate a disk, the target needs to be at least as big as the source. So we're going to create 2 identical disks, one on primary and one on secondary. And oh, no space here. Okay, oh, it was empty. Okay. Now we'll jump over to secondary and add the same. Wait for this to save. Okay. Secondary server, same idea. We'll create a new disk. I think I did 10 gigs. And we'll save this. Okay, so we got that cooking. Let's jump over to the servers. So here's the secondary server, here's the primary server. Like I said, I already have Datakeeper installed. It's very simple setup. You just run the setup and put a license on, and then you're good to go. So Datakeeper is running, but before we open Datakeeper, we got to get the disk management to see these new disks. So here's the new disk we just added. We'll bring it online. We'll initialize it. And we'll format it. Get a volume. Let's pick, how about the R drive? Okay, so that's on primary. Now we'll jump over to secondary and we'll do the same thing. Alright, so we got this disk here. And the drive letter should match, so we'll make this R drive as well. Finish. Okay, so we got those disks up and running, and now we're going to configure the mirror. So you can do it from either node, but we'll start on the primary node, and let's start Datakeeper. And so this is the Datakeeper interface. It's very simple, MMC snap-in, so it's nice. You can plug it in right next to Failover Cluster Manager if you want, create a custom console. But anyway, what we're looking at right now is the server overview report. So this is a picture of the two servers I am currently connected to. So previously I had connected to these servers, just connect to the server. And so they're showing me I have these two R drives that are currently not mirrored. So primary and secondary both have an R drive. The size actually looks a little bit different, and it might have been the way that I formatted them to give you a slight different size. So this is actually important because when you create a mirror, like I said earlier, the target needs to be at least as big as the source. And even if it's 1 byte smaller, we're not going to be able to create a mirror. So in this case, I might go back and reformat the R drive or give it a little more space or whatever I need to do to make sure it's at least 10 gigs. And sometimes you have to even go and look at the exact byte size. But there's an alternative that we can do. Since none of these volumes have any data on them at the moment, we can actually create the mirror from secondary to primary. And it won't matter once it's created, we can flip it back and forth. And it will let me do that because primary is slightly larger than secondary, and that's the requirement, is that the target needs to be at least as big or bigger than the source. So we're going to go ahead and create a job. So remember, I already have the cluster already created on that on these two nodes. So that's kind of step one. You want to have your basic cluster created before you create your first mirror. So we've already done that. Now we're ready to create a job, and we'll give it a name and choose a source. Now remember, I said we're actually going to go backwards. We're going to go from secondary to primary because of the slight mismatch in size. So you can choose the network you want to use for the replication traffic. In this case, I only have one network, and that's fine. It's pretty typical in Azure to just have one, so that'll work. And then we'll choose the target. In this case, we're going to replicate the primary, the network, and the volume all looks good. And then finally, the last screen, we have some options. So we can support synchronous replication, which is typically what you would use when you're replicating between availability zones, or if you want to replicate between regions or hybrid cloud or across any higher latency network, you could choose asynchronous. With asynchronous, you also might want to enable compression to help save on bandwidth consumption, and you can also set a maximum bandwidth, so you can throttle the writes if you need to. But for us, synchronous, no compression, no throttling is the way to go. And then we'll click done. So that initiates the replication process. So the R drive, anything on the R drive on secondary will be replicated to primary. And then we get this pop-up to ask us if we want to register this in the cluster. Now before I say yes, let me open up Failover Cluster Manager to show you there's nothing up my sleeves here. So here's the cluster we created earlier. I still have that SQL Server role that's running with the Azure File Share, the SMB server. So that's already here. And if I look in storage, I don't have any disk currently. So now when I go back here and I click on yes, let me move this over a little bit. I click on yes, go ahead and add that to cluster, jump back to Failover clustering. I see this volume R is now in available storage. The owner node is secondary server. And at this point, Failover clustering thinks this is a shared disk. It treats it just like it treats a shared disk. So I could create, I could run my setup, and when it comes time to pick your storage, it will show you the Datakeeper volume R. So let's go ahead and just show you that that actually is true, and that's what happens. And that volume resource can be used with any cluster resource. So of course we're talking about SQL Server here, but if you're doing file servers, or you're doing Oracle or SAP or anything like that, if you would normally find it in a cluster, now you can build a SANless version. So MSDTC, all your generic service, generic script, generic application, any cluster resource, now you can build a SANless version. Again, this works in Azure. It works in any cloud, so AWS, GCP, on-prem, physical servers, virtual machines, it doesn't matter. So I'm going to create a new SQL Server Failover cluster instance. And we'll walk through this again. Okay. Product key, license terms, feature selection. I'll just do the basic. All right, network name. Datakeeper. It's going to be a name, a named instance. We'll call it Datakeeper, and then we'll next. Okay, we'll put it here. That resource group looks good. This is the magic, right? Cluster disk selection. Look, it recognized that Datakeeper volume R as an available storage location. So the experience is just like your normal shared disk. So we'll select it and we'll go through the process. So I'm going to spare you the rest of the install. Everything else is like a normal cluster install, but now we are using a replicated volume resource from Datakeeper instead of a shared disk. So that's it. We're going to wrap things up now. Okay, so let's wrap things up now. We'll end things with some performance comparisons and some cost analysis. So let's jump into performance comparisons. I only looked at the three solutions that I thought are relevant. I didn't really look at the Azure Shared Disk. I'm sorry, I meant the... I did look at the Azure Shared Disk. Sorry. Performance comparisons. So... I used disk speed, and you can see the parameters I used with disk speed. I meant to say I didn't compare S2D. That's the word I was looking for. So Azure Shared Disk, Premium File Share, and SIOS Datakeeper. We see the megabytes per second. This is total megabytes per second, and the IOPS per second, and then the average latency. So just give you a general idea, the Azure Shared Disk, Premium File Share, and SIOS Datakeeper. Datakeeper outperformed the other two solutions in the IOPS and megabytes per second, and the average latency was just about as low as the Premium File Share. And again, and that's all doing synchronous replication, which inherently has has to deal with the latency on the network. So between availability zones, it's looking pretty good there. And if we look at the cost comparison, so the Azure Shared Disk, you're basically paying for the storage. The monthly storage cost for a terabyte zone redundant storage in West US is roughly $200 for the Azure Shared Disk. A little bit more for file share, but still around the $200 range. Now, Datakeeper is going to be slightly more expensive in terms of your storage cost because you're actually provisioning 2 terabytes of storage. But again, it's local redundant storage, not zone redundant storage. So you're looking at about $245 for a terabyte of storage to support a SAMless solution. All right. Well, I really hope that you gain some valuable information out of this presentation. And if you have any follow-up questions, I'll be glad to speak with you. You can email me right here, david.bermingham@us.sios.com. Here's some ways to get in touch with me through our company at SIOS Tech, us.sios.com. I'm on Twitter at Dave Berm. And also have a blog, clusteringformeremortals.com, so you can check me out there. But once again, thanks for your attention today, and I look forward to hearing from you.